Dear friends, dear colleagues, welcome to the second lesson of this video course on immediate loading according to Dotto De Giri. We have seen in the first part of in the first lecture, we have seen the basic of immediate loading, the basic principle. Now, in this lesson, we will see what we need, basically a kind of checklist of what is necessary. But before we go into this list, let me just make one comment. During this amount of lectures, the implant that you will see mostly is this one, the ankylus. Then you will see very often the second one, that is the Xide. Very rarely some Astra implant. Okay. The reason why you don't see any different implant system is very simple, because I have developed all my literature, all my studies, all my experience on this implant here, because I found them most productive and more keen toward immediate loading. And so maybe other implant system can be better in your hands. But I think it's fair that I share with you what I have developed. And I developed my concept on this particular implant system. And that is why you will see constantly me referring to ankylus, Xide, and Astra. Ankylus has a Morse taper connection of 5.7 degree, has a long taper, so extremely tight. Xide has a butt joint connection with an internal X about 3 mm long, and Astra has a combination of a taper and an index connection that has a little bit a more open angle, about 11 degrees. So this is the checklist of what you need. Abutment, wire, winding tools, and welding unit, and so on. What we will see in this lesson as only the abutment. The rest you will see in the third one. When we talk about abutment, what abutment is better for immediate loading? We have to consider what if this procedure has to be performed on a multiple restoration or on a single, because it's completely different. So let's see the ideal abutment to be used on immediate loading on a multiple restoration. The better abutment is a cylinder. And what we need, the features that the cylinder has to have. The first one is the height. It doesn't have to be a short abutment. Those little abutments, they do not work for immediate loading. We have to have at least 10 millimeters of length. Better, 12, 30 millimeters. A longer abutment can always be cut and reduced. A short abutment cannot be increased in length. So, height. Second characteristic is the thickness, not less than 1 millimeter. Most abutments for immediate restoration are too thin to be used with my technique. So, abutments that are 0.4, 0.3, 0.5, they don't work. You need to have a thick abutment. Second and third parameter now is roundness. We need a round abutment. We don't want to have an abutment that has flat area, angles, corners, undercut. Forget, this is not good. Index. For a multiple iteration, we need a non-index abutment. Index is a problem. Index is okay for a single, but for a multiple, is an additional issue. So forget the index. Metal, non-conductive metal. So titanium is great. Gold, precious, metal, whatever, is not good. And finally, the abutment has to be polished, brilliant, not dyed, coated. All these things doesn't really work for us. Okay, so these are the characteristics of the abutment. This abutment here, for example, this is just an example what the abutment that you commonly see. This is not good for my technique. Okay, so it might be perfect for other kind of approach, but not for mine. Okay, so this I don't want to see. So if your favorite implant system has a cylinder that looks like that one that you have seen in this slide, that is great for me. You don't have to use my implant system. Okay? You can use yours. But if you don't have, then you have a problem. Single restoration. Well, now we need an index abutment. Okay? Because it's a single. So you need an abutment that has some features that avoid rotation, disconnection, dislodging, dropping when tilted, and so on. Okay, so for this reason, there are abutments like this one in metal that has an index. This is Accuris. Accuris is also available in peak or temporary restoration. Okay, so this is all the collection of the abutment that I have developed and Dentsply as manufactured and patented. Okay. So you can see here there are two abutments for implant level, goes directly in the implant connection, side and ankylus. Two cylinders for abutment level go directly on the platform, and the cap for conometric retention, all the entire family. What kind of restoration can we do? Well, we can do three kinds of restoration. Implant level screw retain, abutment level screw retain, abutment level conometric retain. So let's start from implant level screw retain. So if this is the Xive implant, this is the abutment for implant level restoration. It's an abutment, you see, very tall, that goes directly in the connection without an index. And there are three different diameters because the Xive implant has different connection according to the diameter. So you have different diameter. You see here, this is the carrier. See, a good carrier, but it does not protrude enough from the soft tissue. So you can't really use in this case for a restoration. But if you put the dedicated abutment, see now it's much better. You have a lot of metal. Then you can use this to make a restoration that is screw retained directly into the implant platform. And this is your result. Seeing the X-ray, my philosophy, minimal invasiveness, minimal occupation of the biological space, little implant, little abutment, all welded together, very stable. Stability is the key. If your implant preferred is the ankylus, then you have an abutment for the implant level screw retain restoration, specifically designed for this approach, always by me. As you may know, the abutment of the ankylus system are designed in a way that the screw is wider than the connection, so the screw cannot be removed. This could be a problem if we want to make an implant level restoration, As the implant level restoration axis is dictated by the axis of the implant, as we cannot change this, because this is not an abutment level where you can use a MUA, multi-unit here. You have to follow the axis of the implant. So if the implants are pretty much disparallel, then if the screw cannot be removed by the abutment, sometimes you may have a problem in removing the restoration or in placing this. This is why I have designed this abutment here, where the screw is one piece and is capable to be removed by the abutment. So this is very convenient when you are doing a restoration on implant level. But please consider, Ankylus has always the same diameter of the connection, independently from the diameter of the implant. For this reason, you see the abutment are always the same. So you have less inventory. So these are 3 implant Ankylus place, the 3 implant level abutment, and the restoration. Now look at this restoration. How nice and lovely it is. Why is that? Because the best emergent profile you get when the restoration comes is generated from the deep, from the very deep. So if you put the implant deep into the bone, into the tissue, and use a very narrow abutment, you can have a long channel where you can really develop a very nice emergent profile. Look at this emergent profile. This is really fantastic. And this is better achieved with implant level restoration with the Ankylus system. Abutment level restoration, screw retain. Well, the implant system that I work with, all the 3 different brands, they have an internal connection. So, as we mentioned before, implant axis dictates, and this sometimes is not good because, the bone sometimes doesn't allow you to put the implant where you would better place this prosthetically. So this is why the engineer of every company has developed a multi-unit abutment that can change the axis of the implant. So the multi-unit abutment, basically what it does, it transforms the implant from internal connection to an external connection, from an index connection to a non-index connection. And if you use the angulated multi-unit abutment, then you can also change the screw axis. There are 2 cylinders for the XIVE, and this is the multi-unit abutment of the XIVE that is called MP abutment. It's in 2 pieces. This is the straight, and this is the angled. And one characteristics of the multi-unit abutment is, as you can see, that on an index implant, it's just 6 positions. So if the implant is not healed and the abutment is not the ideal position, you can still rotate a little bit the implant. But if the implant is healed, to have an index implant system could be sometimes a problem. So these are 3 implants, 3 MP abutment, and the cylinder, and the final abutment level screw retain. Restoration. Let's now move on the Ankylus. The multi-unit abutment for the Ankylus is called balance base because the Ankylus has just 1 diameter. As you can see, you have just 1 abutment and just 1 cylinder. The only thing it changed is the gingiva height. And it's also in 1 piece. So it's a very good multi-unit abutment. The angle abutment is called SmartFix, and once again, is an excellent abutment. And let me now add one comment here to this point. To every angle abutment. Angle abutments are designed, has been designed to fix a problem that you have. So the best things normally is to avoid having problem. So this means, please place the implant in the good position with the good axis. Do not intentionally misplace the implant so that you can use an angle abutment, because this is nonsense. It is really nonsense, okay? Try to use the angle abutment when it's really necessary. Because the angle abutment are making compromise. An angle abutment, what does it make? It change the axis of the screw. Maybe this is the axis of the implant, right? This is the axis of the implant. And then you need to have the axis of the implant here, okay? And so it changes. How does it make the changes? By changing the axis into a piece of metal, okay? So it gives creates some metal where you can change the axis. So this creates two problems. The first problem is that every angle abutment, the first thing it does, it makes worse your mistake. It worsens your mistake. Okay? If the implant is misplaced, the abutment will be further misplaced in the beginning. Okay? Look at the picture here. Okay? See, at the beginning, this is going in the wrong direction. So it always makes the problem bigger. And then it changes and it fixes your problem, but in another position, a little bit far, 2, 3, 4 millimeters far from the implant, right? I hope you understand this. And you have a lot of metal for this reason, to cover. And sometimes you don't have tissue enough. Sometimes you have a static issue. So my recommendation is use the angle abutment only when this is really necessary. In many cases, they are very important, but not always. I will explain this better in the lecture on full arches. So these are 2 implant plates, 2 abutment, 2 cylinders, and the implant screw retain at abutment level. Third method of retention is conometric. Conometric can be done on multiple, at some abutments that are different when you are doing conometric on single. First of all, what is conometric? Conometric is definitely a new way to make fixed restoration on implant, retained just by friction without screw or cement. It's just a little cap that engages the abutment with some friction, and in a very simple way, you have the most precise restoration that you can ever dream of. If you look at this slice between the cap and the abutment, you can't tell which one is which. And this is really amazing, the precision of your restoration, achieved in a very simple way. So why we need this? Well, we all know the pros and cons of cemented and screw-retained restoration. Cemented restoration. It happened to everybody to leave some undetected cement. You did not realize there is some cement left, and all of a sudden you have a cementitis, a perimplantitis. So there's a problem. Screw-retained is most oftenly used today because of these cement issues. But very honestly, nobody can really like a restoration that looks like a Swiss cheese, cribbled with holes. They are not aesthetic. They are reason for chipping, ceramic, methodologic issues, and so on. So econometric, it is very interesting. Let's say that is the third way to do retention. What's the story behind? Well, one day I was doing immediate loading with my lab technician, Gianluca, and he showed me this restoration with a bunch of holes. And I told him, you know what? I have enough. No more of this. Because really, I don't want to see holes everywhere. So we start working to develop something. In Dentsply, we already have the Syncon concept developed by Dietmar Meyer long ago, long before. And this concept is fantastic, is terrific. It's designed to make direct restoration on a dental patient using this gold copying. And this restoration are supposed to be removable by the patient, although working like a fixed restoration during chewing. However, quite often my patient has problem to remove this restoration. And I am not the only one who complain about this. For this reason, I thought that what it looked like a disadvantage could become an advantage. So why don't we copy the Syncon concept and we add some features in order to make this restoration permanently fixed, removable only by the dentist when necessary. By working on these three parameters, conical angle, friction coefficient, and insertion force, we finally came to the point that if we would just change the copying from gold to titanium, that has 2.5 more the friction coefficient than the gold, we will have more retention. And if we apply an insertion force, a blow on the cap, we will create a permanent engagement. So this is what we did. We create some prototype, and here you see all the family of the econometric abutment. So the first one was a prototype on Syncon. And obviously we summoned relatives of us, grandfather, and we did our first econometric case on Syncon. First, full arch bridge, no holes, no screw, no cement, fixed, removable only by the dentist. This was 2006, so long ago. Then the second step was to convince Dentsply to support us. And Dentsply loved the concept and developed the first official econometric abutment for the Syncon that you can see here. And this was introduced in 2009 in Barcelona, the Dentsply Symposium. And since then, we've been using a lot this abutment to make full arch restoration. When you see thin mandible, unstable denture, so 4 implant, 4 abutment, parallelized, welded together to create a framework, relying the denture on top of this. And here is our final econometric restoration. Place in position, tap, and that's it. No holes, no cement. Fixed restoration. We did a lot of these cases in this year, 2009, 2011, okay? This is the first article ever published on the concept, 2012. Although, as you can see here in the article, it's clearly stated that the case were recruited in 2009. But the journal need 3 years to publish this. So we like this concept very much, but the limit of this abutment is that they are too bulky, and so really we cannot use this abutment in partial dentulous. But now we are become conometric addicted, and we want to do conometric implant restoration everywhere. So in order to do partial, we went on the standard. Standard abutment is a very small abutment, so allow us to restore also small bridge or single crown. And so this is absolutely great to make socket fit restoration or whatever. And this was developed in 2011. The last born in 2018 is Accurist. What is Accurist? It's an abutment with an index to make single crown. Has some difference from the other abutment because it's a little shorter and some other characteristics. Most important is that it has a triangle that works as an index and a cylinder that works for avoid anti-tilting, disconnection during lateral forces. So now with this abutment, we can confidently make single restoration with the conometric concept. So, in conclusion, we have 3 kinds of abutment, 3 lines of abutment in the Dentsply family: standard, Synchron, and Accurist. So, standard has 2 different diameters of the abutment. The connection is always the same, 2.5 millimeters, but the abutment are 3.3, 4.5. We call it A and B. So we have cap, conometric cap, for every standard abutment. The standard abutment has different prosthetic height. So this is the standard. See the small one has 4 millimeters in height. This has 6 millimeters in height. So we have 2 caps. The cap for the abutment, the so-called A4, and the cap for the A6. This is the cap for the B4 and the cap for the B6. So you have an entire family of conometric cap if you want to use different abutment. But if you want, you can use always the same abutment. Obviously, you have many abutments, so according to the anatomy, you can use a different abutment if you want. What are these? These are the parallelizing gauges that are different for A4, A6, B4, B6, as you can see here. So this is the whole family of the standard abutment. Synchron has different kind of abutment, and the cap that you have already seen here. This is the titanium cap that I have designed. You can also use the gold cap if you want, but the retention is less good than this one. So I recommend you use the titanium. By the way, the titanium costs the half of the gold cap and works better. So I think it's better if you use the titanium. Okay, so these are the 3 kinds of caps. Last one is Accurist. Accurist has a line of abutment that are slightly different depending if they are designed for Ankylos, Astra, outside. But basically, the principle is the same. You have three kinds of caps. One is made on PEEK. Another one is made on metal, is silver, and is the lab cap. The PEEK one is to make temporary. The silver one is for the lab technician to work on the model and is not so retentive. It's good for him, otherwise he would go crazy if the cap is too much retentive, as the final one in titanium nitride is. Okay, so there are three types of cap. The final cap is always the gold one. Then you need to have a fixation tool. As you know, you can fix, I have been fixing my conometric restoration for many years with just a piece of wood and a mallet. But you know, this is not very elegant, and it's also different to share the information to the followers. How much force are you applying? It's a little bit too empiric. For this reason, we have designed an instrument that every time delivers the same amount of force. And that is necessary to engage, permanently engage your crown. Okay? So you just grab the device and deliver the spring. Okay? Load the spring and deliver your hit, your blow. If you want to remove the crown, one of the magic of the conometric is that in 1 second you can disconnect the crown or the bridge. Well, with a bridge you can just use a spring bridge remover. But with the crown, you cannot really use the instruments that are available on the market because the cloth is too thin. It doesn't have enough surface area. You need an instrument that embraces the whole crown. That's why I have designed this instrument here that has wide tip, so in a second it disconnects the crown very easily. And also at the stop, as you see here, so it will not crash the porcelain when you disconnect the crown. So it is really a very simple procedure, and is really one of the biggest advantage of the conometric concept, that anytime you need, you can disconnect the crown. In 1 second, you can inspect the implant. If you need to do, you can see if there is a problem in the soft tissue. You can correct the emergent profile if it's for some reason, whatever. And then you take the fixation tool and you permanently engage the crown. So in conclusion, when you use Synchron, when basically you have full arches with a lot of vertical dimension, vertical space. When you use standard, when you do partial, small bridge. Also full arches when you have small teeth and you want to make an FP1, a socket fit restoration. When you use Accuris, when you do single crown. Let me now say the 3 pillars of the conometric concept in immediate loading restoration. We are not talking now of stage restoration, conometrically retained stage restoration. There is another course. The crown is retained by friction. Friction is achieved only when the cap is seated completely. If the cap is seated 90%, you don't have retention. You don't have some retention. You have nothing. It's easy to find out because the crown will pop out. Okay, and so you immediately understand that something is wrong. So for this reason, it's important during the surgery that you remove the obstacles to the fitting of the crown. So you see, I put the abutment here, I grab a probe, I go all around the abutment. If the probe can go, means there is nothing in between. If the probe cannot make a circle, it's better if you disconnect the abutment and maybe you remove a little bit of bone very gently. So this is the first condition. The cap has to be fully seated. Second condition is, well, you need an impulse with a predetermined force, okay? So put the crown and then deliver your impulse. And the third is, on single, everything is okay, but on multiple, the abutment has to be parallel, okay? So it is important that the abutments are parallel. Implant may not be parallel, the abutment has to be slightly parallel. Obviously, you have to consider that the abutments are more or less 5 degrees, so they don't have to be extremely parallel. You have tolerance about 11 degrees each abutment, so you can do this easily and it's not difficult to be achieved manually. Also, you see it in this little animation here. 3 implants has been placed. And they are not being placed very well. You see, they are not so parallel. So this is the first point. Try to place the implant better. Put the implant parallel. It's not difficult when we are dealing with the partial edentulous or a mandible. May not be always possible on full arches, but anytime you can, try to put the implant parallel, because in this way you can use only straight abutment, and this will make your life easier. If you cannot, like in this case, you see the first implant was okay, I put an abutment, 0 degree. The second and the third, I put 2 15-degree abutment, then I rotate. You see in the indirect time, how much time did I take to do this? 10 seconds. It is really very easy. So I rotate this, I find very easy the parallelism, and at this point I tie the screw so they become one piece with the abutment and the implant. Okay? So rotate this. Look at this situation here. This is an anterior maxilla. Anterior maxilla, we know. The bone is not really, normally is not really very good. And so even if you are a great surgeon, you cannot put the implant parallel to each other in most cases. No matter if you do freehand surgery, guide surgery, the bone dictates the axis. But now look how easy it is to find the parallelism of these 4 implants. So you just grab 4 abutment, 15 degrees. Without index, you just tighten it a bit, the screw, not too much, otherwise the abutment will be impacted into the, stuck into the implant. So the abutment can be free to rotate. Okay? So you have placed the abutment, and now you put the parallelizing gauges, they are very long, so you rotate them. Look at the picture, look at the video and see how easy it is to achieve the parallelism. So with the 15-degree abutment, you find, you fix 90% of the problem. It is important in case like this because obviously the dimension of the teeth is not big and we want to use the small abutment, okay? And the same is true for the dentulous mandible, where normally I prefer to put two implants parallel to each other in the front and two implants slightly tilted in the back. Okay? Now I rotate the abutment and parallelize them. Obviously, you can always use computer-guided surgery. Computer-guided surgery has a great synergy with the econometric concept. Because with the good planning, it allows the dentist to parallelize the abutment, the implant, better than if you do this freehand. So, once again, econometric is important anytime that you can to use the straight abutment. Why? Because it's easier. So, when you do the digital planning, try to put the implant parallel. It's not important if to place the implant parallel, you have to put a shorter implant or a narrow implant. Forget, it's not important. Try to put the implant parallel if you can. If you cannot, the software will help you to select an axis that is compatible and can still be fixed with the abutment, angular abutment. And this is what you can do with simpler software. What literature do we have on the econometric concept? Well, I have published a number of articles, and there are 14, in the reality is now 15 articles published, and more are coming. So you can find a lot of science and evidence on the econometric concept. We will go more in the detail when we will go in the clinical work in the next lessons. Now, so, when do we do implant level restoration screw retain? Basically, when we have a very poor implant stability because implant level abutment, they do not engage the index. So even a little torque, an implant with a very poor torque, can support an implant level abutment because it doesn't apply any force on the index. When you have very, very small, limited vertical space, because the implant level abutment can be reduced as much as you want, when cost is an issue, sometimes it looks like it is. Implant level, you just use one abutment for every implant. Abutment level, no matter if screw retain or econometric, you use two abutments for every implant. For some people, this makes a difference. Anytime you want to make a two-step restoration, cemented restoration, or you're working with referrals, most referrals, they still want to take impression of at implant level. So it's better to make implant level bridge, so you just screw the bridge in the implant, and the referrer will just open the hole, take the screw out, take the bridge out, put the impression copy, and work the way you like to work. And sometimes anatomic, as you have seen, the emergent profile in some cases is nicer with the implant level restoration. Okay? When do we use screw retain restoration at abutment level? Cantilever length. Well, with econometric, because the abutment has to be parallel, cantilever is always a little bit longer compared to screw retain, especially when you make a screw retain at abutment level and you do not correct the axis. We will see that when we talk about the full mandible. But if you don't tilt too much the implant and you do not correct the axis, so you don't use multi-unit abutment to correct, in this case, you shorten the cantilever. That is very important. If the implant is not really placed in the best position, look at this case. 4 implants. Yeah, I know, too many implants. Why did you do that? I don't know. But it happens to be made like this. And now I have an implant that is in the lingual root of the future crown. It's okay surgically, but conometric, it works in addition. So you have an abutment, then you have another abutment, and then you have the crown. Although the abutment is very thin because the cap is 0.4 millimeter, but you are adding. So if the implant is poorly placed, then your restoration will be a little bit more bulky here, as you can see. And some patients will not like to have this extra volume in the mouth. On the contrary, if you have a screw-retained restoration at abutment level, the nice things of the cylinder is that the lab technician can always enter in the cylinder, can always invade the space, remove the lingual wall of the cylinder, and create more space for the tongue. So with screw-retain, you see you have more space for the tongue. If the implants are placed a little bit lingually, it may happen for a number of reasons. Maybe conometric is not a good idea and better to do a screw-retain. Stability. As we said, conometric needs 25 Newton of torque, because you have to tap and pull and tap and pull. It's better to have 25 Newton, even if it's a multiple. We have seen in the first lesson, single 25, multiple, even 15 is okay. But with conometric, it's 25 for single and 25 for multiple. Sometimes you don't have this. Sometimes the implants are not so good, the stability. But you need to go on. So what do? You combine orange and apples. So you put screw posteriorly and conometric in the front. It's not the best solution, but this is one possibility when you don't know how to do, when the torque is very poor and you still have to go on with loading. So this is another advantage. So when we do conometric, in conclusion, well, honestly, I would say, with my heart, I would say always. In my office, we strive to do conometric whenever we can, because conometric is fantastic. It's so much better and it's so much improving the quality of your work, the quality of your life and of your patient life, that you will always try to do conometric. However, as we have seen, sometimes you cannot use it because the insertion torque is not good enough, cantilever would be too long, implants are not centered, and your learning curve is still at the beginning. It's not a steep learning curve, but there is just a learning curve for everything that is so much new, like conometric. Okay, so in conclusion, conometric is first choice. Whenever we cannot use conometric, we will go for screw-retain at abutment level and less often at implant level. So this is as much for this lecture. And now I wait to meet you again on lesson number 3, where I will discuss the material that you need to make immediate restoration with the intraoral welding unit. So I look forward to seeing you in chapter number 3. Bye bye and arrivederci.